Okay, so some other things we need to take a look at for your lab are evidence of pollution. Okay, that right there, that thing sticking out, is a piece of reinforcing rod. That's definitely not supposed to be there. Okay, and if you take a look at the stream itself, getting down to where you can see it, okay, you can see that this tree, like the roots are starting to stick out of the water. And over here, this tree, I'm walking to get to where you guys can see it. Ooh, it's a little deeper. You can look at the roots of this tree and then the tree a little bit downstream. Whoa. Okay, you can see how the roots, like all in here, are out of the water. Tree roots are not supposed to be out of the water. Okay, so there's definitely erosion on that side of the bank. Okay, and you can also see that there's erosion on that side of the bank because the stream is, the bank is steeper on that side than on this side. Okay, so there's definitely erosion. That tree way up there last year looked a lot like this tree. So in one of the big storms that we've had since last year, because we were out here on October 1st and today is October 4th. In one of the big storms that we've had, what wound up happening is that the water was rushing so fast, or the wind had blown so hard that, and the tree was unstable on the bank because the roots were sticking out so much, and it went into the creek. So there's some evidence of pollution and erosion. Okay, so I'm going to share with you guys a little bit about why, when we saw the evidence of erosion at Kingwood Park, why erosion happened where it was happening versus why the opposite of erosion, which is deposition, was happening where it was happening. Okay, so where I was at Kingwood Park, I was on a bend. And we noticed that this side was eroding. So it was steep. And we noticed that this side was depositing. It was a gentle slope. Okay. And you could tell that it was depositing because there was like a bank here where I, stood and I did all my tests. And the tree roots were all sticking out on the eroding side, okay? So it has to do with something called hydrodynamics. Don't panic, I promise, okay? So, and it relates to something that you guys might have seen. Let me pull this in. Here. So if you ever watch the Olympics and they do like the 400 meters or any of the longer races, they have a staggered start. They don't line up straight across the track. The guy on the inside starts back and the guy on the outside starts further out. And it may make you wonder, like, why does that happen? Well, I'll pull this up too, and we can talk about it, okay? So let's say, let me go back to my ink mode. Let's say all of us are standing here, 1, 2, 3, 4, 5, 6. We're linked arm in arm right at this point, okay? And we want to walk around the track in that direction. So the question is, who's going to have to walk fastest, or is anybody going to have to walk fastest if we stay linked in that straight line and walk from where that starting line is towards this point over here? Okay. Who's going to have to walk faster? Who's going to walk slower? Well, if you look at this, right? If you look at these as the radius of a circle,
the inside radius is a lot smaller than the outside radius, okay? So the outside of the circle, the outer lane in the track, so this guy right here, has a bigger distance to cover than the inside, than this is lane 1, okay? So they got a bigger distance to cover. So in this case, if we're all like locked arms standing right here, the person on the outside is going to have to walk faster in order to keep up. And the person on the inside is really not going to have to walk anywhere near as fast, okay? So if you've ever watched the marching band at halftime, like on a college football game or even our band, where they do any like turning moves, right? So the person in the middle, so the person in this case in lane 1, is going to pretty much just walk in place, right? Whereas the person on the outside is really going to be booking it to get around with everybody else, okay? So the same thing applies to our stream. Go back to the previous page, okay? If we think about water moving around the bend, the water, let me change my color, the water out here is going to be moving faster than the water on the inside. So the water on the outside of the stream is going to be moving faster than the water on the inside of the stream. So if water is moving faster, it has a greater power to erode or pick up materials. So that's why you have like the tree branches sticking out here, and then you have deposition on the other side. So that covers everything we need to cover for why there's erosion versus deposition. Hopefully that helps.